Hello everyone. Today we are going to work on a very important video on an IC called L293D, and this IC is basically used as a motor driver to drive motors. So basically this IC takes input from an Arduino, controls from the Arduino, and gives output to motors and makes the motors work faster or slower or change their directions or whatever. We will be using uh, this IC in Tinkercad, but we will be using uh, its motor driver version. I'm giving you a picture here. So basically, this will be used by us physically when we actually creating our robotic cars or robots or whatever. So first things first, let's learn about this IC. What is this motor driver? This is a small chip that lets you control the direction and speed of DC motors and stepper motors using a controller like Arduino or Raspberry Pi. Think of it as a traffic controller that decides on when and how a motor should move. Whether it should go forward or backward or stop, or how fast it should go. What are the features of this IC? It's uh, it works on a dual edge bridge concept. Now this basically is a concept that can be explained in a different video, not in this video. But basically, it lets you control motors, and motors basically the change of direction of the motors. So, dual edge bridge is basically for the change of direction, not the speed, but the change of direction if it is going forward or backward. To change the direction, I would physically have to change the connections uh, to the electricity, whatever. But without changing the connections, if I want to change the direction of a motor, I will have to use a dual edge bridge, which is the concept that this IC basically uses. Voltage support, it can handle voltages up to 36 volts and currents up to 600 milliamperes. Whereas the Arduino's output is only 5 volts and the current is a fraction of this. So Arduino cannot be used directly to run motors. They can control motors, but they cannot run motors. Direction controls, you can make motors move forward or reverse. And anyway, enable pins can be used to turn on or off the motors. Um, this IC receives control signals from the Arduino. It powers the motor using an external battery. So that means I will be using an external battery, maybe a 9-volt battery for the motors and a 5-volt for the Arduino. Um, and it also protects the Arduino from back currents generated by motors. So that part done, let's work on the actual pins of these motor of this IC. Um, this is basically a 16 pin IC. You can see on the left hand side from pin number 1 to 8 and 9 to 16. I've given a description of all these pins from 1 to 16, 8 on one side and 8 on the other side. Now let's see how we go about it. Let's work on the power pins. Power pins basically we have 4 ground pins, that is pin number 4 and 5 and pin number 12 and 13. So these are directly connected to ground, so these should be the easiest to work on. The next easiest to work on are the 2 power pins, basically the power 2 and power 1. And you can see power 1 is basically connected to a 5-volt power. This power is for the IC itself, and we can take this power from the Arduino itself. Whereas power 2 is basically the power for the motors, and this power will be taken from a 9-volt battery or any other kind of a battery. and that will be connected to pin number 8. Okay, so ground pins and power pins are done. So that means 6 pins are done. Next pins are the enable pins. So enable pin is pin number 1. So pin number 1 is basically used to enable pin motor 1. That means if enable pin 1 is not connected to power to 5 volts, motor 1 will not work. So to make motor 1 work, pin number 1 should be connected to power 5 volts. Similarly, pin number 9 should be connected to power, that is 5 volts again, if we want motor 2 to work. So that means if pin number 1 and 9 are not connected to 5 volts, both the motors are not going to work. It doesn't matter whether we are doing whatever else is right. So enable pins are also done. So all we need now are the input pins and output pins. And you can see the input pins, there are two input pins on one side, pin number 2 and 7, and there are two input pins on the other side, that is pin number 10 and 15. I've also given which pin are of the Arduino are they going to be connected to. So pin number 2 is going to connect to pin number 2 of Arduino, pin number 7 to pin 3 of Arduino, pin number 10 to pin 5 of Arduino, and pin 15 to pin 4 of Arduino. So I'll tell you more about input 1, 2, 3, and 4. Basically, these are used to change the directions of motor. So enable pins basically enables the motor. That means whether it will work or not, that is pin work of pin number 1 and 9. But pin number 2 and 7 and 10 and 15, these are two pairs which when they are connected as high low or low high, that will make the motor reverse or go in the forward direction. So changing of direction is through pin 2 7 for the one motor and pin 10 15 for the other motor. Lastly, we connect to pin number 3 and 6. To pin number 3 and 6, we connect the first motor, and to pins 11 and 14, we connect the second motor. Okay, now this part is done. Let's start working on the actual circuit. Alright. The actual circuit is like this. Uh, Now this connection, this is already done. So let me start the simulation and see, yes, both the motors are working. Alright, both the motors are working. So uh, what I'll do is I'll remove everything from here and connect everything again. Okay. First things first, we need an Arduino. Let's bring the Arduino here. Let's bring the breadboard here. Let me change the orientation of this breadboard. Let me bring what else? A battery here. I need again one is 5 volts, but we'll take it from here. But 9 volts, we'll take it from here. We need L293. So this is the IC that we need. Let's change the orientation of this IC also and place it somewhere there. Place it a little down here. Okay. What else do I need? I do not need anything. I need motors. I'll bring the motors a little later. Let me do all the connections now. All right. If I look at the connections, so if I look at the pins, you can see that the pins. These are the pins. You can take a screenshot of this, and you can also write them down. Okay, it is best to write them down so you'll remember them. So in case I give this as a program in your robotics competition, you should be able to do it. All right, the screenshot done. Let's start working on this now. First things first, I need to give it power. So let's give it power. Let me give it power for 5 volts. So 5 volts comes from here and ground comes here. So these two are done. Let me color this as black. Connect the negative here and let me connect the positive. Negative and positive both are done. Um, what do I need to connect positive? Let's see. Okay, we need enable. We need the enable pins to be enabled. So if we want them enabled, they should be connected to positive. Where is the another enable? This is the second enable. I'll connect to positive. Two are done. So both the enables are enabled. So both the motors will work when everything is done. Let's see the ground. These are the two grounds right in the middle of these two grounds. So I'll connect these two grounds with a black and then connect this to the ground. Okay, connect this to the ground. Okay, and these two are also ground, so I'll connect these two grounds and then connect this also to the ground. So this part is also done. All grounds are done. What I need is an input. Input I need to connect to Arduino pin, so I'll connect that later. Okay, we'll connect that now. So what is that now? Power 2. Power 2. Power 2 is basically the 9 volts power. So power 2 is this one. So this is the 9 volts power. 9 volts power connected to the positive of the battery. The negative of the battery is connected to the ground rail. When we are using two circuits like this, both the grounds of those two circuits should be connected together. The positive should be separate, but the ground should be connected together. So you can see that the negative of this battery is actually connected to the ground of the Arduino also. But the positive of the 5 volts here is never connected to directly to the positive of this battery. So that should be clearly understood. So output, okay, what should we do first? Let's do the inputs first. So this is the input port, and as I told you that the input of pin 2 should be connected to pin 2 of the Arduino. So let's connect it to pin 2 of the Arduino. Let's color it as green maybe. So once this is done, so second is the pin 7 of, that is this pin. This is the second input pin. This should be connected to pin number 3. So let's connect it to pin number 3. Connect it to pin number 3. Done. There are two more input pins on this side. So input pin 4 is connected to, so pin number 15 is connected to pin number 4. So let's connect it. Let's connect it to pin number 4. It's connected to pin number 4. Let's pull this thing down. And lastly, pin number 10, that is input. This input should be connected to pin number 5. Please check the pin uh, figure that I had shown you. You will be able to see. I think all the connections are done except for the output. So output 4 is left, output 3 is left, output 2 is left, and output 1 is left. So for that we actually need a DC motor to come into the picture. So let's bring in DC motors. This is the DC motor. Let's change the orientation. Let's make a copy of this because I need two motors. I have brought in two motors. One motor I'll connect it to, so this is the output 4, right? I'll connect it here, and the second to output 3, that is. Okay, I'll change this to positive and change this to a negative, although it doesn't matter which to which. Only thing is, if the connections are not done correctly, the motor will rotate in the opposite direction, but it doesn't matter to us right now. So we have two pins to work on, that is output pin 1 and output pin 2. So we'll connect the motors to on that side. So we'll connect the motor on that side and the second over here. Let's make this red just to color it a bit better. Right, so this is done. I need the code. Let me just bring in the code. Okay, the code is already written, so I'll just copy the paste the code here. I'll explain it in a little while. I'll explain this whole thing in a little while. Let's start the simulation and see what happens. Stop the simulation. Is anything left out? Oh my god, this power pin is left out. Okay. This power pin is left out. So this power should be is actually power 1, which should be connected to this. So power 2 is connected to the 9-volt battery and power 1 is connected to the Arduino, that is the 5-volt thing. So yes, both the motors are working perfectly fine. Perfect, perfect, perfect. I'm very happy. Alright, done very fast. Okay. Now let's understand the code now. You can see that L1, L2 are two variables basically corresponding to the first motor and R1, that is to the left motor, and we can see this is the right motor. So there are two variables for the left motor, two variables, yani ki two pins for the left motor, two pins for the right motor. And you can see the numbers are 2, 3 and 4, 5. We have specified that all of them are for output, means they are not giving input, they are taking out. Now see how we figure out how to change the directions. See, L1 has been given a high, L2 has a low, and R1 is a high, R2 is low. So when L1, L2, L3, R1, R2 are basically given in this order, high, low, it will go move in the forward direction. But if it was L1 was given a low and L2 is a high, let me change this now. Let me change this to a low and let me change this to high. What do you think is going to happen? One motor is going to go in the reverse direction, one is going to go in the forward direction. You can see now. The upper motor is going in the reverse direction, minus RPM, and the lower one is going in the positive direction, positive. If I want both of them to go in the reverse direction, what do? I make this as low and I make this as high. Now please remember, I am right now hard coding everything, but we are going to do it this whole changing through switches or potentiometers or whatever we are going to use as input. In the next video we will be doing that, how to do it, because a car is going to change its direction if it, for example, a robotic car finds an obstruction in front. So an ultrasonic sensor is going to detect there is something which has come in front. Now it has to reverse. How does it reverse? It changes the high low kind of a thing to a low high, and the car reverses in direction. How is it started and stopped? That starting and stopping is done by the enable buttons. So we'll be doing that later on. But let's see the simulation now. Both are going in reverse. So sorry, one is going in reverse, one is going in the positive direction. Okay. So low high. How is it going? No, both are going in the positive direction. Okay. I think we should be okay with whatever we have done till now. Okay. If you have any problem, just go back and first of all write down all the pins. Write down all the pins. It's not a very difficult task. It's not a difficult task. And then figure out how to connect everything. Try to connect as I have connected, and then make it work. Okay. In the next videos, we are going to give inputs to this particular system, and which is going to change the direction of the motors or the speed of motors or stop the motors or whatever. Okay? So that we will be doing in the later videos. I hope you have understood. Thank you for watching. I'll see you in the next video.